This is my design of probably the smallest ESC for triple phase brushless motors you can find out there. It is only 8mm wide and 2cm long. But is it perfect? Yeah, it is, obviously. Nah guys, just kidding. It still has some small errors, but it works almost as expected. As you all know, I've made a lot of ESCs on this channel, and my last version works as any other commercial ESC, reaching very high speeds. But I wanted to make a smaller version, the smallest I could possibly make it. So this time the circuit is a lot simpler. I've used very small components that could still be soldered by hand, and I've also made a 4-layer PCB. So let me take you to my journey of making a few versions till it finally worked, so you could also learn how to make one. So guys, let's get started. What's up my friends, welcome back. Just to compare, here I have some of my previous ESCs based on Arduino. Starting from my first prototype ever, to my small and powerful ESC that could work as a commercial one, using sensorless feedback and reaching very high speeds and also torque. But the PCB I've made for today's project is only 8mm wide, and here you have it on the tip of my finger. And the reason I have this PCB in multiple colors is because this is the third version. Because believe it or not, even if the circuit is simpler, the project got more difficult because of that. So if you want to try the same project, you could download my final Gerber files from below and try it out. Maybe you could improve it. So go to PCBWay.com and click the Code Now button. And on this page you add the settings such as the size, the amount and the color. In this case this is a 4-layer PCB, so I select that option. You save to cart and on the next page I upload the Gerber files. Place the order and in just a few days you receive some very small PCBs. And they look great as always, so let's get started. This PCB is as simple as having a microcontroller with a 60 MHz resonator, the programming pads, 3 P MOSFETs and 3 N MOSFETs. The rest are just simple capacitors and resistors for pull downs and pull ups, because everything is done in the code. All the sizes are 0402, which I'm still able to solder by hand. But the first version was using 0201 resistors and capacitors, as you can see on this PCB, and because it was very difficult to solder, I've ordered a new version. And the second version, which has this purple PCB in this case, had a different problem with the feedback resistors. So finally this is the last PCB, which still has a small error, but at least I know that it works, and let's see how. This is the schematic. The Atmega 328P microcontroller in a QFN package, so it occupies less space. The triple phase bridge with P and N MOSFETs. The power input pads, the pads for programming, and the phase out pads. And finally we have some resistors for the feedback detection. Before we solder the components, I want to show you the differences from my previous ESC circuit. Look how more complex is the previous circuit. This small ESC will work at 5 volts, so I've got rid of the voltage regulation. Because the chip and the MOSFETs will work at the same voltage, I've also got rid of the drivers. And the feedback doesn't need a voltage divider, so instead of 9 resistors I can use just 3, just to limit the current. Okay, now just to make it faster, I've taken the Atmega chip from an old Arduino clone. In that way I know for sure that it has a bootloader. So first I've soldered the chip, the resonator, the reset pull-up and the DTR capacitor, so we could test it. I've tested if the microcontroller works using one of these FTDI programmers. And on the PCB I have the R, the T and the D pads corresponding to RX, TX and DTR. And for VCC and ground, you could use the power input pads. Once I know it works, I solder the rest, starting with the 0402 resistors. And soldering these small components by hand is not that difficult. Just have some patience, and it's a bit easier using soldering paste. Then I've added the MOSFETs one by one. Now that is ready, I want to test it, so I've connected a small brushless motor like this one at the output. But as you can see on this thermal camera, some MOSFETs are getting very hot. And that's because the P MOSFET that I've used on the PCB design has the source and the drain pads reversed. And that's the error that I mentioned at the beginning. And that's why, finally, I've soldered 3 of the MOSFETs like this. It looks ugly, but at least I can test it. Having this thermal camera helped me a lot to find out which component was failing. So I used the FTDI programmer to upload the code. And if you check the code, you will see that it uses the PCInt interruptions on pin D8 to read the PWM input. And then this is the comparator interrupt on pin D6. That's where the feedback 0 cross is connected, as you can see here on the schematic. And depending on the feedback, we can change to the next part of the sequence. We have the 6 steps of that sequence. And depending on the step, we activate the pins that go to the MOSFET bridge. And that's it. I upload it and I make some tests. I had to tweak some variables for the ramp up part in the code, but it finally worked. I used this servo tester to control it. I connect it to the ESC and at the output I add one of these very small brushless motors. It can't work with big motors, because the maximum current value would be around 2 amps or so. I power it at 5 volts and no more than that, because it will burn the chip. And there you have it. It can reach a decent speed. Here I measure that speed. And it reached 16,000 RPMs, which is amazing. I can't measure the torque right now because I don't have a setup. Now, is this working perfectly? Well, no. And that's because during the tests, it was resetting all the time. And I think it's because of the current peaks. I've added a capacitor at the input and that improved the working time, but even so, after some minutes it will reset. So obviously I have to fix that, because I would not rely on an ESC that might fail at any moment. Also, the Atmega 328 is quite sensitive to the voltage input fluctuations, so maybe using a different microcontroller would be better. But this was a very good start for my micro ESC, and I bet it will get a lot better. I've done the same with my previous ESCs, till they've got very good, so it's just a question of improving and improving. If you want my files, you can download them from below, but have in mind that this is just for prototyping. I can't assure you a finished product. I hope that you have learned something new, and if so, consider giving me a like or comment below. Thanks again, and see you later, guys. So guys, here I am in my workshop, another video that ended. I hope that you like it, and the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel, so thank you very much once again.